This is problem number 1 from section 3.1. In this problem, they say use the graph to find the following. And we have a graph here, and we have like 5 different things we need to find. So part A, it says the sign of the leading coefficient. Part B is the vertex. C is axis of symmetry. D is intervals where f is increasing and where f is decreasing. And finally, E, they want the domain and the range. Let's start with part A. So part A, they want to know the sign of the leading coefficient. Well, I have a quadratic here, and the quadratic is opening upwards. Anytime you see a quadratic opening upwards, our leading coefficient here is positive. If it's opening downwards, our leading coefficient would be negative. So because it's opening upwards, the sign of the leading coefficient, we're going to say it's positive. Part B. What's the vertex? Well, the vertex is always the point when you go from a decreasing to increasing. So at this point here, right at the bottom, we have the vertex, because at this point we go from decreasing to that point right there. Now we're increasing afterwards. So the vertex is that spot where we go from decreasing to increasing, or vice versa. Now, with a quadratic, that vertex is also going to be the spot where essentially this quadratic reflects. So this -2 for an x value is where it also reflects as well. Now the vertex here, that's just the coordinate that we need. So the vertex is going to be -2, comma -1. So -2, -1, that's the vertex. Okay, and we'll write that out there, vertex. Part C, axis of symmetry. Well, the axis of symmetry we just talked about, this -2, this point is the spot where it reflects. The axis of symmetry is actually the vertical line that's imaginary, where this quadratic is reflective across. If you see, or I guess you can see that if you were to fold this paper across, the lines would be over top of each other. So this is called the axis of symmetry right there. Axis of symmetry. Now, that's the axis of symmetry, and we represent that with a vertical line, and that would be x equals -2 is what the axis of symmetry would be. Right, we just say that that's the imaginary line that's there that separates the two sides. Part D, then it says intervals where f is increasing and where f is decreasing. So we know that we're increasing to the right of the vertex, increasing to the right, and we're decreasing to the left of the vertex. So increasing to the right, decreasing from the left. So we're increasing from x value of -2 all the way up to infinity, right? We're going this direction, right? This line's going to keep going this direction. So we're increasing from -2 to infinity. And we're decreasing from -infinity, and I'm going to put those on the number line. -infinity's out there, infinity's here. We're decreasing from -infinity up to the x value of -2, the vertex. And I'm going to just write that these are x values. Right, because that's how we describe where we're increasing. That's how we describe where we're increasing and decreasing. We're specifically talking about the input values. Finally, E is the domain and the range. So the domain of this function is what can we plug into the function. Well, as you can see, the function goes on forever in each direction, right, from left to right. So -infinity to infinity is our domain, right? We can plug anything into this function. But the range is talking about the output, right, which is the y values. The lowest y value that we obtain is -1. And then we go all the way up to infinity. So the range is -1 to infinity. And that's how you look at a graph, a quadratic, and come up with the important pieces of information. We know that it opens upwards, so it's positive leading coefficient. We know the vertex is that spot where we go from increasing to decreasing. We know the vertex also represents, if we draw a vertical line, where we have the axis of symmetry. And then we also know that the increasing part is from the axis of symmetry to the right, and the decreasing is from the left to the axis of symmetry. And we wrote that in there, and then we also found the domain and range.